All right, continuing again on with 2.8. So we're on example 9 and we're just going to solve and graph this. So we're going to do the same thing. So we're going to need to find, first thing, it has a 0. So we're going to cover this. So greater than 0 means we're looking for positive numbers. It has the equal to, so that means our x-intercepts will have brackets. Remember, the vertical asymptotes always have parentheses. All right, so for my x-intercept, we're doing our critical values. So the first one is our x-intercept, so that's where our numerator equals 0. And we said it would have a bracket because it has the equal to. And then our vertical asymptote, which is where the denominator is equal to 0. Well, remember, the only way that this can equal 0 is if what's inside is equal to 0. And so it said x equals 4. And we said vertical asymptotes always have parentheses. All right, so set up your interval table. We have our interval, our x's, our y's, and our signs. So always start at negative infinity. And it goes to the smallest one, which is -1, which has a bracket. Then we go from -1 to 4 that has a parenthesis. And then 4 is our largest, so it just goes to infinity. Pick some x's in each interval. And let's plug those into our equation and see what we get. All right, so I plugged in -2, and I got approximately -0.2. I plugged in 0, I got 0.25. And I plugged in 5, and I got 6. Now, so I'm like, uh-oh, what's going on here? But remember, what do these have in common? These have that 4 in common. That 4 came because of that absolute value, okay? So that can change little things that happen as well, and that's what happened here. All right, so it's okay that we have that plus there. All right, so we're looking for where they are going to be positive, and we can see it's positive on both of these. So from -1 with a bracket to 4 with a parenthesis, union 4 with a parenthesis to infinity with a parenthesis. And so there is our solution. All right, example 10. Now, example 10 is just, well, it's not a polynomial, but it doesn't have a fraction, so we don't have to worry about the denominator, but we do have to be careful because we have the square root. And remember, we don't take the square root of anything if it's not greater than or equal to 0. So, we got a couple things to watch out for. So, first thing is, I'm going to check and just see what x's are we able to use. And so, the restriction in this domain here would be that our square root itself has to be greater than or equal to 0. So that means x plus 1 has to be greater than or equal to, I said greater than and then I wrote less than. Greater than or equal to 0, square both sides, x plus 1 is greater than or equal to 0. So x has to be greater than or equal to -1. Can't be less than that. All right, then to find our x-intercepts. We're not going to have any vertical asymptotes because we don't have a fraction here. But our x-intercepts are where our factors, so the x minus 2 is equal to 0, and the square root of x plus 1 is equal to 0. So we solve both of these. We get x equals 2. This one we get x plus 1 equals 0, which means x equals -1 is an x-intercept. Now when I look at my inequality, we can tell we're looking for less than 0, so we're looking for where it's negative. And our x-intercepts are going to have brackets. Okay, so the 2 and the -1 will have a bracket. All right, so my intervals, x's, y's, and the signs. So my interval is going to be from -infinity my smallest critical value there, the -1 with a bracket, the -1 with a bracket to the 2. I'm sorry, the 2 should have a bracket as well. And then the 2 with a bracket goes up to infinity. Now, we have two ways to think of this. One, if you happen to realize the wait, we just said it can't be less than -1, so this first interval is not going to work for us. But let's just say we forgot, so we're going to check it anyways. We're going to see something that's going to happen there. All right, and so then I pick an x in that interval and pick an x value in this interval. So we're going to plug these in. And so I notice when I plug in that -2, it gives me an error because I end up with the square root of -1, which is imaginary. So this just doesn't exist. So I don't want to put that. So we can't do this one, and that's because it doesn't work. It's not in our domain. Because sometimes we might not remember to check the domain. So this is just a double way to make sure we didn't miss it. All right, so when I plug in 0, I get -2. And when I plugged in 3, I got +2. And so we said we're looking for where it is negative. And so there's our interval. So from -1 to 2. Guys, make sure you write out what your interval is. Don't just kind of circle it there in the table and hope I realize it's that interval, not the y value you're trying to tell me is the answer. Okay? All right, then let's look at example 11. It says it's challenging, but I think y'all can do this. All right, so the first thing I notice is doesn't have 0 on one side, so I'm going to move that over. And I need to combine my fraction, so I'm going to find that least common denominator, which is the 1 minus x. And so I'm going to multiply just this side by 1 minus x. So I get x squared minus 3x minus 10 minus 2 times the 1 minus x all over the common denominator of 1 minus x greater than or equal to 0. Work on that numerator, distribute, and then combine like terms. So distribute that -2. Combine your like terms. And I didn't write it there, but greater than or equal to 0. Now, because when I do doesn't matter if I do it here or I do it when we go to find those x-intercepts, that numerator can be factored. And so I'm just going to go ahead and factor it. Has to multiply to -12 and combine to -1, so x minus 4, x plus 3. All over 1 minus x has to be greater than or equal to 0. All right, so those critical values. My x-intercepts where my numerator is equal to 0. So x minus 4 equals 0. X plus 3 equals 0. So we get 4 and we get -3. And looking at my inequality, I see it's got that equal to, so they're both going to have a bracket. Vertical asymptotes where my denominator is equal to 0, so 1 minus x. And so we end up with 1 equals x, and these vertical asymptotes always have parentheses. All right, so my interval, x's, y's, and the sign. So -infinity to the smallest one, which is -3 with a bracket. -3 with a bracket to the next smallest, which is 1 with a parenthesis. 1 with a parenthesis to the next smallest, which is 4 with a bracket. 4 is also my biggest one, so we're going to go 4 with a bracket to infinity. Pick some x values. And let's plug them into our equation to find our y value. -4, I got 1.6. 0, I got -12. 2, I got 10. And at 5, I got negative 2. And looking back, we're looking for it's greater than 0, so that's positive numbers. And so I can see where it's positive, so negative infinity to negative 3, union 1 to 4. Make sure your parentheses and brackets are correct. All right, example 12. So A says a ball is thrown vertically upward from the top of a 190-foot building. The distance above the ground can be modeled by that equation there, where t is measured in seconds. During what time period will the ball's height exceed that of the tower? Solve using algebra. So we want to know where the height, so that negative 16t squared plus 96t plus 190 is going to exceed the height of the tower, so it's going to be greater than. And how tall is the tower? So they're talking about the building, so it's 190 feet. All right, so we just need to solve this. So let's get it with a 0. So move the 190 over. So we got negative 16t squared plus 96t has to be greater than 0. All right, let's go find those critical values, which in this case is just our x-intercept. So remember, we're going to set this equal to 0 and solve. Greatest common factor out negative 16t. So it's going to leave me with t minus 6. And set each factor equal to 0. Now, one thing you do have to think about on this one as well is, remember, it's a word problem, so it can have domain. T is time, and what do we know about time? Time can't be negative, so our time has to be greater than or equal to 0. So when I do my interval, there's no reason to go from negative infinity to 0. We're just going to start our table at 0. Or we can put it, but we're just going to mark it out because we know we don't need to do it. I think that might be better. All right, so we do our intervals. So if I put negative infinity to 0, remember, time can't be negative, so this is just not going to work for us. Now notice we're looking for greater than. Sorry, wrong one there. I need to check that one. We're looking for greater than, so we're looking for positive, and our x-intercepts are going to be parentheses, okay? So we're going to go from 0 to 6, and then 6 is our largest to infinity. So we're going to pick some x values there. We're going to plug them into our equation. So at 1, I get 80. And at 7, I get negative 112. And we're looking for greater than, so we're looking for positive. So there is our answer. So 0 to 6. So what does that mean? That means that the ball is going to be above 190 feet from 0 to 6 seconds. All right. Moving on to B. Florida Paper Products has a contract to design a box with a volume of not more than 200 inches cubed. Squares should be cut from the corners of a 15-inch by 18-inch piece of cardboard with the flaps folded up to make an open box. What size squares should be cut from the cardboard? All right, so on this one, what we're going to have is we have this piece of cardboard. It's going to be 15 on the short side, 18 on the long, and we want to know what size we need to cut out these little pieces. So we don't know, so we're just going to call them X right now. And so what I have is right here on this piece, it's just 15 minus the 2 X's that we have at the end. And then this piece inside here this is going to be 18 minus the 2 x's that we have on the ends. Now, something to think about, if this side is 15, it's our smallest side, we have that domain restriction, okay? So our domain, if that x is coming in from both sides, means that, well, 15 divided by 2 is 7.5. So that means that we can't have a side, or a square, excuse me, we can't have a square that's more than 7.5 inches, because then it'd be more than the side of the entire box. So our restriction is the x has to be no more than 7.5 inches. So it has to be between 0 and 7.5. All right, so what we have here is we have our length. That's going to be our 18 minus 2x. We got our width, which is 15 minus 2x. And then when we're talking about volume, because it did give us inches cubed, which is volume, and it says volume. So we need to know how high is this box going to be. Well, we're going to take like this little thing here, and it's going to fold up. This side right here is my height, which will be x. So remember the volume, or let me do this, length times width times height equals volume. So we know that the 15 minus 2x times the 18 minus 2x times the x equals the 200. Now let's see what it says here. It says a volume of not more than 200. So this has to be less than or equal to 200. And so we need to work out this side here so that we can get this with 0. So I'm going to go ahead and multiply it out. So I get 270 minus 30x minus 36x plus 4x squared. And then I still have that times x at the end. I'm going to put that at the beginning here. So I have 270 minus 66x plus 4x squared. And then I'm going to distribute that. So 270x minus 66x squared plus 4x cubed. And that just looks really weird to me, so I am going to switch it around so it's in standard form. So 4x cubed minus 66x squared plus 270x. And this is still less than or equal to 200. All right, so remember it has to be 0, so we can tell if it's positive or negative, so I'm just going to move that 200 over. So 4x cubed minus 66x squared plus 270x minus 200 is less than or equal to 0. And so we need to go through and find our x-intercepts. All right, so in order to find these x-intercepts, we've been factoring, but this one's not factorable, so we got to find another way. And so one way we can do it is we could do our p's and q's to find us one that starts. Or what I'm going to go ahead and do is I'm going to use my calculator to help me because we are, well, you're not, but I am almost out of class time to record this. So I'm going to put this in my calculator, and I'm going to find me an x-intercept to start with. So 4x raised to the third minus 66x squared plus 270x minus 200. And I put all that in the exponent, of course, and I got to do it again. And so when I look at this, it looks like maybe 1 or 5. So I'm going to check my table. At 1, it's at 8, so that's not 1. But 5 is at 0, so I know 5 is 1. So I could use my calculator to find the other, or I'm just going to do that. So we know x equals 5. And now remember we said it has to be between 0 and 7.5. So anything smaller than 0 won't matter, which when you look at our graph, I don't see anything on my negative 10 to 10 scale. So I don't see anything less than 0. So if I did, though, I wouldn't take it. And the only one between 0 and 1.5 I have the 1 at 5, and then I have that one that looks like it crosses at 1, but it doesn't. So I'm going to go through and I'm going to do my second 0.